AI-driven transformation of the public sector. Similar to the revolutionary impact that AI is having on the private sector, it will also help to transform the public sector, where we already see practical use cases, especially with respect to improving public services delivery, bureaucratic efficiency, as well as public safety and security. If AI is applied with wisdom and in a responsible way, it could be a major asset to any country and a source of global competitive edge. In most countries around the globe, citizens unfortunately have in general a bad experience and low satisfaction with public services and its delivery modes, as it is typically inefficient with slow response times, backlogs, inaccuracies, redundancies, and poor quality. There are also problems with limited transparency and corruption. AI-driven technologies and platforms can help to significantly improve public service delivery and efficiency by enabling citizens to engage with governments without friction, make it easy to voice their opinions, help them to coordinate their efforts, and even avoid overseeing from public authorities. AI-enabled automation can help to make administrative processes more smooth running, efficient and faster, help to address resource allocation constraints, increase productivity, and reduce cost and the typical data entry and analysis, paperwork, backlog, and tasks involved with mundane, manual, repetitive, and redundant processes. In a Deloitte Center of Government Insights report about AI-augmented government and how AI can be used to redesign public sector work, they show that for the US federal government alone, task automation can deliver potential savings between $3.3 billion, task speed up by 20%, and $41.1 billion, task speed up by 200%. Apart from task automation, AI can also be used to provide more accurate predictions, detect anomalies, assist with real-time tracking, increase effectiveness, and help with better decision-making. Intelligent virtual assistants and chatbots can provide 24/7 support, increase responsiveness and engagement levels with citizens. A citizen intelligent virtual assistant can, for example, help with applications, recruitment, support, public facilities, and notifications, whereas government-to-business intelligent virtual assistants can assist to improve services and interaction with companies and non-profit organizations with respect to API services, permits, and compliance. The same holds for improving internal government-to-government services and interaction. Not only will these AI-driven service delivery solutions enhance citizen and business participation, but enable them to also communicate their preferences and assess the effectiveness, quality, and usefulness of public services as input to improving services and making better policy decisions. Similar to the innovation that we see in the business sector, smart technology can help governments to create innovative and better forms of service delivery, be more proactive in how it responds to citizens' needs from a social services, education, healthcare, safety, and emergency perspective, and provide better care and management of critical systems and infrastructure with predictive maintenance and defenses against cyber attacks. There is also some contrasting dynamics at play with governments. On the one hand, gaining smart technological powers to increase their control over citizens based on ubiquitous surveillance systems and ability to control digital infrastructure, but on the other hand, also faces mounting pressure to alter their current approach of making policies and engaging with citizens, as their central role of conducting policy lessen as a result of the decentralization and reallocation of power and the introduction of novel sources of competition. These dynamics force governments and the public sector to become more agile, efficient, and transparent as they adapt to the disruptive quick changes of the environment and remake themselves to ensure their continuation, regulate in a more pragmatic and relevant way, and improve their services, interaction, and collaboration with citizens and the business sector. Deloitte has in Government Trend 2020 report highlighted some of the most transformational trends in government with respect to currently implemented government operations across developed and developing countries alike. Governments that are augmented by AI can improve end-to-end public service delivery via a unique digital identity to enable a more efficient and seamless personalized citizen experience and treating citizens, businesses, regulated entities, and government employees like customers. It can also use behavioral science to improve government outcomes and encourage good behavior via promising lower costs and better outcomes whilst respecting human autonomy. AI-augmented governments can further manage ethical complexities to ensure privacy, equity, and transparency across their operations, as well as from a regulatory perspective. Such governments can also anticipate problems through predictive analytics across many areas of government and touch on, for example, social services, food safety, to law enforcement. As in the business world, cloud-based infrastructure provides a foundation for innovation and implementing state-of-the-art smart technologies at scale. Safe experimental environments such as accelerators, incubators, and labs can also be created to innovate from healthcare to currency, whereas smart city solutions for the public services landscape can range from mobility to healthcare to the environment and expand it to regions, rural communities, universities, and military bases. There is also an opportunity for these governments to promote public trust in AI, demonstrate its potential benefits, assist with creating demand, and develop the local AI industry by providing opportunities to address various governmental needs. Although public service delivery typically accounts for a substantial proportion of government budgets, the increased spending is often not matched by improvements in outcomes. According to ATOS, the projected worldwide spending on AI for the public sector will be approximately $9 billion in 2021. China has a multi-billion-dollar plan to become the AI world leader by 2030. Accenture estimates that globally, AI will help to double annual economic growth rates and increase labor productivity up to 40% by 2035, and at the same time could create almost $1 trillion in economic value in the sector across 16 major developed economies. In the same report, they mentioned that the IDC projects that governments will see the second largest AI spend of any industry by 2023. The IDC has recently also reported that spending in AI and smart technology is likely to accelerate across the public sector as a result of automation and social distance compliance required to tackle the coronavirus pandemic. Whereas governments use smart technology to assess social distancing compliance, it is also implemented to help fast-track COVID-19 diagnosis and testing in hospitals and in the form of intelligent virtual assistants providing advice, guidance, and support to patients in self-isolation. From a public safety and security perspective, AI-driven solutions can also add significant value with respect to crime prediction and prevention and help to reduce the crime rate, which is the number of reported crimes per 100,000 total population. Although there has been a decline in crime rates in many countries, criminal activities are still a serious problem that many countries are facing, and where smart technology such as AI, big data, Internet of Things, drones, and augmented reality are increasingly being used to help the police to ensure public safety and control crime. In order for governments to prevent crime, AI can assist by analyzing huge volumes of data to find patterns that can be useful to law enforcement. In, for example, the South African context, which is unfortunately also currently one of the crime hotspots in the world, AI use cases involve the discovery of patterns, diagnostics, predictive analytics, and prescriptive insights for specific crimes such as violent crimes, for example, murder, rape, car hijackings, cash-in-transit heists, cash point robberies, farm attacks, kidnapping, xenophobic violence, financial and property crimes, for example, building hijacking, asset stripping, advance fee fraud, municipalities, targeting of government auditors, lawyers overcharging clients, and theft, smuggling, and vandalism, for example, arson, power grid, livestock theft, housebreaking, school plunder and vandalism, drug smuggling, and consumption. The more connected, instrumented, and smarter the infrastructure, the more real-time information can be fed to AI systems to help detect criminal activities as soon as they happen. Some AI-enabled crime detection use cases include detecting gunfire, bombs, and clues on a crime scene. For example, a company called ShotSpotter provides a precision policing technology suite that can detect, locate, and alert on gunfire in less than a minute, provide tactical data such as multiple shooters or automatic weapons, create automated data-driven patrol plans for crime deterrence, and provide investigation and forensic services for crime scene and incident research. Amongst the many companies providing AI-powered video surveillance systems that are also used for crime detection and prevention, Hikvision is one of the leaders that provides AI-enabled security cameras that recognize faces, read license plates, recognize vehicle attributes, count customers, manage queues, and detect unattended bags or hard hats. From a crime prevention perspective, AI use cases involve predicting crime spots, the people likely to commit a crime, and supporting decisions on pre-trial releases by analyzing risk factors. As an example, Pret Paul, which calls themselves the Predictive Policing Company, has AI-based solutions that can provide location-based proactive policing and insights, help to allocate and manage patrol resources more effectively, and predict critical events based on crime type, location, and time. In China, CloudWalk is using AI to predict if a person will commit a crime before it happens through the use of facial recognition and gait analysis, which measures how people move when walking and detecting anomalous movements and suspicious behavior. On the spectrum from assisted to augmented to autonomous intelligence, there are many AI applications for national and international security and defense in areas such as intelligence, surveillance, reconnaissance, command and control, cyberspace, cybersecurity, logistics, and predictive maintenance. The Department of Defense in the United States defines intelligence, surveillance, and reconnaissance as integrated operations and intelligence activity that synchronizes and integrates the planning and operation of sensors, assets, and processing, exploitation, and dissemination systems in direct support of current and future operations. In order to locate and understand the intentions of potential enemies, a wide spectrum of sensors such as videos, imagery, acoustics, and communications, as well as platforms such as aircraft, ships, humans, and satellites, collect, analyze, and share data, information, and intelligence across multiple warfare domains, which includes subsurface, maritime, land, air, space, and cyber. Some of the intelligence disciplines include signals intelligence, geospatial intelligence, measurement and signatures intelligence, publicly available information, and human intelligence. Due to these large data sets available for analysis, AI is very useful for intelligence, which is the product of surveillance and reconnaissance operations. AI-driven computer vision enables videos and photos from uninhabited aerial vehicles to be analyzed and hostile activity for targeting to be automatically identified. So, the work of human analysts who currently spend significant time filtering through videos for actionable information can be automated in order to allow them to use their time more efficiently. As mentioned earlier, AI is enabling more and more realistic video, photo, and audio falsifications or deep fakes that enemies could deploy as part of their information operations. A real worry is that countries could even use deepfake technology against one another to not only generate untrue or distorted news reports, but also weaken public trust, influence public conversation, deceive forensic analysis, and attempt to extort government officials. AI-enabled dynamic behavioral profiles can also be created for suspected intelligence officers, staff, government officials, or private citizens. AI can also enhance cyberspace, cybersecurity, and military cyber operations by training models to detect anomalies in network activity patterns that will enable a more comprehensive and dynamic barrier to attack. Similar to applications in the industrial world, AI can be applied to enable predictive maintenance and optimize logistics within a military sphere. To increase availability and avoid reactive repairs, the Army and Air Force can, for example, develop tailored maintenance schedules for a fleet of vehicles or aircraft instead of having standardized fleet-wide maintenance schedules. Command and control are another important application area for AI that combines information from various domains, automatically resolves variances from the input data, and provides analytics and insights to a comprehensive common operating picture of friendly and enemy forces for monitoring, strategy, and decision-making purposes. Similar to the progress with AI applications on the commercial, semi-autonomous vehicles front, where it is used to perceive the environment, recognize obstacles, fuse sensor data, plan navigation, and communicate with other vehicles, AI is also being integrated into military, semi-autonomous, and autonomous vehicles such as drones, fighter aircraft, ground vehicles, and marine vessels. Another controversial application area is lethal autonomous weapon systems, which are a special class of weapon systems that use sensors, AI, and other algorithms to identify in unassisted fashion a target and utilize an onboard weapon system to engage and destroy the target without manual human control or involvement with the system. A US Department of Defense directive described human-supervised autonomous weapon systems as a subset of these fully autonomous weapons that are designed to provide human operators with the ability to intervene and terminate engagements, including in the event of a weapon system failure before unacceptable levels of damage occur, which is contrasted with semi-autonomous weapon systems that, once activated, is intended to only engage individual targets or specific target groups that have been selected by a human operator. There is currently strong international debate and opposing positions about autonomous weapon systems, and little progress has been made so far since the establishment of the United Nations group of governmental experts that started discussions in this regard. I also participated a few years ago in a Future of Life event with Max Techmark, where we specifically informed African leaders about the dangers and risks involved with lethal autonomous weapon systems. The problem is to also get the major military powers to take a unanimous stance on lethal autonomous weapons. It seems like the US, Russia, and the UK has been consistently opposed to a ban on these weapons at this early stage, where China has been more ambiguous in this regard. As advances in smart technology, on the one hand, will help to potentially reduce the impact or scale of present-day and future violence, strife, clashes, and warfare, they are also capable of causing harm, damage, and suffering on a massive scale, especially with the use of lethal autonomous and biological weapons that are becoming easier to use and more accessible. This has significant implications for public safety and security from a national and international perspective, as the world is becoming a more dangerous, complex, and uncertain place to navigate. As the weaponization of AI has been increasing at a rapid rate, it has become a high priority security issue across countries globally. Although we have made progress with data privacy regulations and data have its origin, boundaries, and ownership, the problem is that there are, for all practical purposes, still no rules, borders, or regulations for AI engagement on a national and international law level. Although there have been some agreements on cybercrime, we still have an absence of agreements on AI standards or AI's use for warfare.